Okay, so let us continue yesterday's problem. Okay, so what we were discussing, that is what all possible palindrome strings over the input alphabet A and B. Okay, so all possible palindrome string here includes what? The palindromes of even length as well as odd length as well as the epsilon. Okay, so this we have seen. In case of odd length palindrome, what we have seen earlier example, we have designed the DPDA. Okay, so in that case, odd length, what we did before we get the middle symbol, all the previous symbols, it may be A or B, those are pushed onto the stack. And whenever we get the middle symbol, beyond that middle symbol, then for each symbol that is read, for that one symbol pop from the top of the stack, and we are checking whether those are matching. Okay, if the symbol read is A, the pop symbol must be A, otherwise the input is rejected. Okay, similarly beyond that middle symbol, if the symbol read is B, then pop symbol must be B. Okay, so that was in the odd length palindrome strings, but this example includes both cases. So here we have seen we cannot design here the DPDA. Okay, DPDA is what? For each input symbol, there is only one transition from one state to the another state. Okay, and in case of NPDA, what? There can be more than one, that is more than one possible transitions from one state to the another state. Okay, now the logic that we applied for the odd length palindrome, here same logic will apply for the even length palindrome. Okay, but in case of even length palindrome, what happens? There is no so middle symbol, no even length palindrome. Suppose this is my palindrome AA, this example we have seen. So what we have to do, half of the this string we have to push onto the stack, and for the remaining half we have to compare it with the earlier half. Okay, but to separate this in this case, then we are going to insert a epsilon as a middle symbol in case of the even length string. Okay, so in case of even length string, what is done? Middle symbol push is a what, or considered is a epsilon. Okay, and now the logic here is what yesterday we have seen, and I have already told you to find the equations for this. Okay, so what we did here, to push the half of the string, so whenever we read A or B, those are pushed onto the stack and we remain in the same state. Okay, now for the middle symbol, so what we have seen, the middle symbol can be A, B or the epsilon. In case of odd length string, middle symbol can be A or B. In case of even length string, the middle symbol is a epsilon. Okay, so that's why we are here, we also consider the transition from read 1 to read 2 state on A, B or the epsilon. Okay, so that's why here it is the what? NPDA, because NPDA is what? In the read 1 state. Okay, for in the read 1 state, for A, there are two outgoing edges or two transitions. From one transition is from what? Read 1 to read 1. It remain in the same state. Okay, it push A onto the stack and remain in the same state. And another transition for A is what? It changes its state from read 1 to read 2. This is not push. Yeah, this middle symbol A, B or epsilon, these are not push onto the stack. Only it changes the state from read 1 to read 2. So this is what our middle symbol. And after that, what is the logic our? That is, after the middle symbol, for each symbol that is read, what we have to do? Pop the symbol from the stack. If the read symbol is B, the pop symbol must be B. Okay, then we continue the reading the input string till we reach the end of the string. Similarly, if the read symbol is A, the pop symbol must be A, then only we continue, okay, reading in the same state. And in the read to, if you get the blank, okay, at the end you have to always check whether your stack is empty or not. As here we have seen there are two ways: acceptance by the final state and acceptance by the empty stack. Okay, so in our examples, what we have considered? Acceptance by the empty stack. Okay, so in the read to, after reading blank, you have to also check whether the stack is empty or not. Okay, so if the stack is empty, then accept it. Remaining edges we have not shown indicate that what? Those are the reject state. Okay, only if you reach this state, only in that case your string is acceptable. Okay, so while writing the equation, you can write the equations for whatever you have shown in this diagram. Okay, so for writing the equation, what I have told you, you have to consider the states. Okay, so the states here are read 1, read 2. Input alphabet, I told that A, B, epsilon, and the blank you have to consider. But what I told, you consider A, B, and epsilon only for the read 1 state, as there are outgoing edges here for A, B, and the epsilon only. Okay, similarly for the read 2, outgoing edges are only for the A, B, and the blank. So you can consider only the transitions for the read 2 for those symbols. And here the stack alphabet is what? A, B, and the blank. Okay, so stack symbols can be A, B, or the blank. Okay, so now what I told you, have to write the equations for this. Okay, is there anyone who has tried writing the equations for this? We have continued yesterday's problem only, no? So has anyone tried? If yes, you can put it in the chat. Whether you have written the equations for this or not. First, tell me whether this is clear, why this is an NPDA. Should get the difference between NPDA and DPDA. Yes, is it clear? Yes, Atharva, number 6.
Yes, ma'am.
Is the difference clear? NPDA and DPDA?
Yes, ma'am.
Okay. So have you tried the equations, writing the equations?
Yes, ma'am. I written it.
Okay. How many equations you got?
15.
Huh?
15.
15. Okay. Let us check. All the remaining students, you can put it in the chat, the equations. Okay. So you know now what are the possibilities that you have to try. Okay, let me adjust this one. Okay. So first, what we'll do? Okay, let the diagram. Oh. So transition. Let us write the equations first for the read 1 state. Read 1, first we'll consider the input symbol as A, and for the input symbol A, what I told, you have to consider all possibilities for the stack symbol, and stack can be what? A, B, or the blank. Okay, so let us consider the stack is blank. Let us first consider this edge. Read 1 A, push A, and then. So what is the next state? Yes, Atharva, if you have written, you can tell me what is the next state?
Read 1.
Yeah, correct. And the stack content?
A.
A and the blank.
Blank.
Yeah, A is pushed onto the top of the stack, correct. Next is now, read 1 will consider A only, and now the stack top symbol is A. Okay, so what is the next state now? Next state, we are considering this case only, correct? We are following this HC, read 1, we are reading A, and then we are considering all top stack symbol. So here again it remains in the same state, yes, and the stack content is A, correct one, yes. So for the read ones, consider A, and now the B. Here again the same thing. No, we are following this age only. For this, we are considering 3 possibilities. Okay, so it is now what? Read 1, and A is push onto the B symbol. Okay, so read 1 we completed. For the A, and stack can be blank A or the B. Top stack symbol, this is what. Now we consider in the read 1 another input symbol. This H will follow, that is B. And again the 3 possibilities. Stack can be blank, stack can be A or the B. Stack top symbol. So what is the next state? Yeah, you can type it in the chat window. What is the next state? Next state and the stack content. Yes. Same way, no? Read 1 and this B is push onto the top of the stack. So it is B and the blank. Please practice this writing the equations, understand this, because otherwise it is very difficult if you don't understand how the stack works. Okay. So now read one, B, and we'll consider the top stack symbol as a A. Here again, it remains in the same state and B is pushed onto the top of the A. Okay. The third possibility here for the, this is what? Read one, then A, okay, and then the, sorry, B. Okay. So read one, this B is pushed onto the top of this. So which edges you have completed? See, this is the NPDA. So which edges we have completed? This one and this one. Right now we can consider the transition from read one to read one on reading A, on reading B, and considering three possibilities for the stack blank A and B. So we completed 6 equations. Now this transition we have to consider read one. What are the possibilities? Read one to read two. We have to consider, no? Okay. So read one to read two. What are the possibilities? See, who will tell me? Read one. Now here I am considering A, and let the stack top symbol is A. Here, what this indicate? You are reading A and the top stack symbol is A. In this case, what? The stack is not changed. No, we are not pushing or popping any symbol for transition read one to read two. We are just reading a middle symbol. This is what middle symbol, and no action is there. That is, we just move our head pointer to the next symbol. So in this case, only the state is changed to the read to. Okay, and the stack top symbol remains this as it is. This A I have written as it is. See, understand this. For read one to read two, this A is the current, that is middle symbol, that is read, and the state is changed to the read to, and the stack is not changed. Is that clear or not? This transition. Please let me know whether you got this transition or not. Read one to read two. Whether this is clear? How we did read one to read two? Is that clear? Yes or no? What are the other equations? Read one. Same. Now for the middle symbol, B, or let us consider A, and the stack top is B. So what happens here? The state is changed to the read to, and the top stack symbol remain as it is. Okay. So this we consider the possibility for reading A, and the top stack symbol can be A or B. Now consider read one. If you are reading B and top stack symbol is A. This is I am considering for the transition. So no operation is done, only the state is changed to the read to, and top stack symbol remains as it is. Similarly, we'll write the equation for the read one on reading B, and the top stack symbol is A, B. So state is changed to the read to, and the stack top symbol remains as it is. Okay. So this we completed for A and B. Let us consider for the epsilon. As I told, epsilon we are considering for the even length palindrome string. So read one on reading epsilon. Your stack may be A or B, top stack symbol. In this case also the state is changed to the read to, and the top stack symbol remains as it is. Okay. So this is how we have written the transition from the read one to read two. Is there any problem or in this? Whether this next 6 equations are clear? We have written 12 equations. This is for read one to read one transition. This is for read one to read two transition on reading the middle symbol. Are the equations clear? So we'll consider the equations for the read 2 state. This we completed from the read 1 state. Yes. I put yes or no, so we'll continue. Yes, Rohan, are the equations clear? Okay, so this we completed for the, yes, Rohan, yes, okay. So we'll go for the read 2 state now. Read 2 के लिए what I told, from the read 2, the what we have to consider, read 2 on B, we are going to consider only this possibility. Other cases are rejected. If you want to write, you can write it. Let us consider. Let us first write only for the acceptance. So read 2, read symbol is B and pop symbol is also B. In that case, what is my next state? We'll tell BB. What you have to do? Pop that B from the stack and remain in the read 2 state only. Yes. So what is the next state and the stack content? Read 2 BB. Next state is what? Read 2, no? And this B is popped from the stack. So it is a epsilon. Okay. So why I have not written the remaining? You can write the remaining. See, if I read to B and if the stack symbol is A, naturally it is what? It will be rejected, no? This should be BB. No, box symbol should also be and read symbol should also be B. So it is rejected. So we have not shown here the reject state. So you can write if you want. Otherwise, anyhow it is going to reject it. Okay, so I have written this for the read to BA. Another case kya ho sakta hai? Read to B blank. Again you will reject it. Okay, so next we'll consider now the read to A. In this case again what? You are remaining in the same state and the A symbol is popped from the stack, so it is a epsilon. Okay, so what remains? Only one transition, read to blank. Here again you can write other two cases. Can you write the other two cases? Can you write the other two cases? Yes. Can you write the other two cases? Read to A. Other two cases क्या हो सकते हैं? Read to A blank. Read to A B. In that case, it will be rejected, no? Okay. So those two equations you can write. Here also you can write the remaining equation and just check. So read to now on reading blank. If you get the blank, what is it? Read to blank blank. What is it? Read to blank blank. Okay. So now here what we have to check? Why it is a NPDA? Let us check what are our equation. So for the same input symbol, if there are multiple transitions, we know it is a NPDA, non-deterministic. So here you can see, if I consider the equation, let me check. If I consider this equation. Okay, so what is here transition? On reading A, top stack symbol is A, change state to the read to and stack remains as it is. Another transition for the same here. Always remember we need the three values here. What is this? Current state, current input symbol, and this third one is what? Top stack symbol. Okay, and same here you can see. Same hai na? These two are same. Read one AA, read one AA, but there are two possibilities. Yes. So for the same input, there are two transitions. One is from read 1 to read 1. Another is from state read 1 to read 2. In this case, what? A is pushed onto the top of the stack. So the stack contains is that wise A. Here, nothing is done on the stack. So stack remains as it is and just the state is changed for the read 1 to read. So that's why here, this is an NPDA. Same case is there for BB. You can check. Where is the another case? Yeah, this one, no? Read one. This is, and here is some other one. Read one. This is, another is what? For the BB. Yeah, this one. This two also. What? And और कौन से है एनपीडी के लिए? सेम इनपुट के लिए देर आर मल्टीपल ट्रांजिशंस. और कौन से है? विच आर द अदर? रीड वन ए बी है क्या? जस्ट चेक. रीड वन ए बी. या read one AB. This is another case. Read one AB and another this one. Yes. So you can see for the same input there are multiple transitions. So it is a NPDA. Yeah, read one BA is also there. Yes, read one BA. And where we have written read one BA के लिए, this one. Read one BA के लिए again there are two actions. One is changing state from read one to read one. Another is from read one to read two. Okay. So because of this is a non-deterministic PDA. Earlier examples, if you check, there will be only one possibility. Yes. So here it is a NPDA. So now for this same, so my question here is that this is a NPDA. So can you design the DPDA for this example? What can be done? Or whether there exists a DPDA here for this example? Like in NFA and DFA, what we have seen, we can always convert NFA to DFA, and both NFA and DFA have the same power. That is, both non-deterministic finite automata and deterministic finite automata accepts the same set of languages. Now, here my question is what? This is an NPDA, non-deterministic push-down automata. Can you find equivalent deterministic push-down automata? Guess the answer. You can put it in the chat. Can I convert the same NPDA to the DPDA, which will accept the same language? Okay. Any other answer? Other students, please try to guess. Your answer may be yes or no. We'll discuss it, but please answer. Yes or no? Can I convert this to the equivalent DPDA? DPDA is what? I'll show you the earlier example. DPDA. Okay. Yesterday's example of what? Odd length palindrome. What we have seen here, you can see. Read one. Outgoing age for A is only 1. Outgoing age for B is only 1. Read one. Outgoing age, this is for X and this is for the blank. So you can see for every input symbol, there is only one transition. So this is a DPDA. And in this case, what we have seen, this is a NPDA. For the A, there are 2 transitions. Similarly, for the B, there are 2 transitions. Okay, so only Rohan is giving answer. What about the other student? Is my question clear? Can you find equivalent DPDA, deterministic push-down automata, which will accept the same set of language? Yes, other student. Okay. So I got 2 answers as a no. Is there anyone who is saying yes? Other student, at least no or yes, you can say that no. I got only 2 answers. That is no. Okay, 3. Any other? Yes, Sanket. Sanket, can you find equivalent DPDA? Okay. Saurav, number 28. Saurav. Saurav, are you there? See, now onwards, what I am going to do, whenever I am calling you, either you have to answer it in the chat or you can unmute and give the answer. If you are not giving the answer, I am going to remove you from the meeting. Just logging and it is of no use. If you are not physically attending it, there is no use of just attendance. So from next lecture, remember, give the messages to your friend that I am going to remove you if you are not going to answer it. Okay, so what is final answer? Yes, Saurav? Saurav Garje.
Yes, ma'am. I'm calculating that only.
What you are doing?
I'm trying to analyze, ma'am. I'm not able to understand, so I'm trying to analyze.
Is my question clear to you?
Yes, ma'am. F2 yes, ma'am.
So this is what our language. So what is my question? Can you design DPDA? ये NPDA है, ये समझ में आया?
Yes.
Okay.
Yes,
So
ma'am.
DPDA करना है means what? There should be only one outgoing edge for the A, for the B. So can I remove this and modify this in such a way that it is a DPDA and it will accept the same set of languages? Okay, so later on you can try it. So my answer here is that you cannot here find equivalent DPDA because here you can see NPDA is more powerful than the DPDA. But we know that in real situation, we always need the things to be deterministic. Okay. For the machine or program, how it will understand that is after reading in the read one state, after reading A, whether I should follow this path or whether I should follow this path. There is a conflict. No. So NPDA is not useful actually, but we cannot design DPDA for this NPDA. The NPDA is more powerful than the DPDA. So in that case, we may have to consider some other machine. That is the next time we'll study that next unit. That is the Turing machine, which is more powerful than this. Okay. So let us take the one example for this and simulate it. Let us take the small example and simulate it, and then we'll discuss the relative powers of NPDA, DPDA, NFA, DFA. Okay. So take the input string as a ABA and the blank and simulate it. So make the 3 columns again, current state and reply me fast now. Now, Saurav, I'm expecting answer from you. Stack contents, type and the head. So what is the input string that I told you to consider? That is A, B, A, and then the blank. We'll also consider the even length. Okay, so this is an odd length palindrome. So what is our logic we have used? Till we get the middle symbol, we have to push the symbols before that to that middle symbol. Okay, and beyond that middle symbol, you have to read the symbol. For each read symbol, you have to pop the top stack symbol. Okay, so initially stack is blank. You always start with the start state. Okay, after the start state, what is the next state here? That is a read one. So transition from start to read one. After reading, यहाँ पे आपका pointer कहाँ पे था? A पे. So read one will read the current input symbol. What is the current input symbol read? Here is now A, and we'll move the pointer ahead. We'll move the pointer to the B. Okay. So after read one, can you tell me the action now, Saurav?
Yes, ma'am. Push A.
Yeah, correct. So you will push A, and so stack, how you have to show? You show like this way. It is close at one end because you can always perform operation at only one end. Yeah. So A is push on the stack, and now here your input is pointer is pointing to the B. After the push A, we know what is our next state. It is the read one. So read one will read now what? The input symbol, that is here B. So you have to show that B here. So the stack remains only as it is. So after reading B, your input pointer will point to the A. Now what is the next action? Divya? Divya, what is the next action? Divya, number 27.
Ma'am, push B.
See, is the answer correct? If you push B, can you match the remaining half of the string and check whether it is a palindrome? This is how it is here. It is a non-deterministic. Yes, Hunain, it is correct because B is what? Your middle symbol. Again, I have told your logic is very important here that we have already written. That is what? Half of the string you have to push onto the stack and remaining half you have to compare with that. No, that is what the logic of palindrome. No. So B, whatever symbol read here, it was a middle symbol. Blank, don't consider blank as a part of your string. That we have considered to end the string. No. So B here is a middle symbol. So we have to do the transition for the middle symbol here from read 1 to read 2. And this read 2, it will read now the next symbol. Now the next symbol read here is A. And so your pointer, input pointer will point to the blank. Now in read 2, what is the next action? After read A, it is a pop 1. So what the pop 1 will do? It will pop the top stack symbol. So symbol from the stack is pop. Your input, you can see, your input is also ended, no? So input pointer is pointing to blank. Pop symbol is A. After the pop 1, you are again in the state, which state? Read 2. And now the read 2 will read what? Blank. After reading blank, your pointer is moved. Remaining all characters are considered as a blank, no? So after read to blank, what we are checking whether the stack is empty or not. So my next action here is what? Pop 3. And this pop 3 pops what? Blank from the stack. So you can show the stack as a, nothing is there on the stack, no? So pop 3 blank. What is my action now here? This is accepted, no? Yes. So finally it is accept. So why there was a confusion, Divya? Because it is NPDA. See, why you were confused here? You said that push B. Same way, machine will also confuse, no? So for the B, how the machine will know that we have reached the middle of the string? Yes. Here manually we know that we have reached the middle of the string. So we have to now change straight to the read to. So practically, it is not possible to implement NPDA. Yes. So now the next I'm giving you what? Simple example. Let us, this was for the odd length, odd length string. Now consider even length and stack contents, type and the head position. Okay. So let us consider my input is AA. Remaining characters are blank. We know how we have to start. Blank. Current state is start. Yes. Now will tell me even length है तो middle क्या consider करना है हमें? What is the middle character that is to be considered for the even length string? Epsilon. Correct. So let us start. Start के बाद next state is what? Read 1. So read 1 will read A, move the pointer ahead. So what is my next state now? Who will tell me now? This is very important to make the decision now. What is your decision now? Whether you have read the half of the string, manually we are considering, machine के लिए तो possible ही नहीं है, because machine always need a fixed set of rules, no? Yeah, read one correct है, but what this read one will read? That is my question. यहाँ पे इसको लेबल क्या देना है मुझे? या ये जो हमने ए रीड किया है that is correct. So we'll push A, and the A is pushed onto the stack. Correct. Now after push A, next is all here read one only. So what this read one will read now? What decision you will take here so that your input string is correctly accepted? Yeah, that is correct, because you have already read what half of the string, correct? A. So 2 length hai na uska. So we have already read the half of the string. So this read one, it will read the epsilon and it will change state to, yes, it will go to the read 2, no? So my next state here is what? Next action is read 2, correct? So this will read epsilon. Still input pointer will remain to A only, no? So after read 2 now, this read 2, it will read what? This A, and will remain in the same state. No, read 2 के बाद, sorry. Read 2 के बाद क्या है action आपका? And your input pointer will move to the blank. Read 2 के बाद, after reading A, what is the action? Next. Yes, यहाँ पे मेरा क्या आना चाहिए? Pop 1. This should be pop 1, correct. Pop 1 क्या करेगा? Pop 1 will pop A from the stack, and now the stack is blank. Input this AA you show as it is. So input pointer points to the now blank. So after pop 1, my next action is what? Read 2. This read 2 will read blank. Yeah, complete this. There is no space for me. Blank, blank. So read 2 will read blank. After that, what is the next? Next action क्या है? Pop 3, yes. Pop 3 के बाद blank आएगा and the input is accepted. Is it clear? Is it clear NPDA problem? So now we'll discuss the relative powers of NPDA, DPDA, NFA, DFA. Okay. So you should always remember that Chomsky hierarchy. Okay. Let me tell what we have seen. Type 0. Type 0 is also known as a what? Unrestricted language or unrestricted grammar. Type 1, context sensitive language. Type 2, context free grammar, and type 3 is a what? Regular grammar. So what is here? Say the same way we'll use to express it. Let me first, what is the most powerful, or any language can be generated. So I'll just draw, this is your inside this, and inside this. So what is it here at the outer, which is the most powerful? Type 0, always remember, other name is what? Unrestricted language or grammar. This is type 1, type 2, and type 3. Okay, so we know that type 3 is what? It is a regular language, and type 3 is accepted by, type 3 is a regular language, and it is accepted by what? Finite automata. You should always remember this. Then only you understand which language is accepted by which machine or automata. Okay. So type 3, which is the least powerful, you can see. This is the least powerful, no? Most powerful is type 0. Type 3 is a subset of type 2, type 2 is a subset of type 1, and type 1 is a subset of type 0. So it is accepted here by the finite automata. In the finite automata, then we have seen two types, non-deterministic finite automata and the deterministic finite automata. Okay. Then we have seen how we can convert NFA to the DFA, and then we have seen both NFA and DFA have the same power. They are of the same power, means both accept the same set of languages. Okay, so that was related regarding type 3. Then we have seen type 2. What is a type 2? Type 2 is a context-free grammar. And the language accepted by this, it is known as a what? CFL. Okay, so this type 2, now we have seen it is accepted by the non-deterministic push-down automata. NPDA, non-deterministic push-down automata. Here there are two types. Again, we have seen NPDA and the DPDA. Okay. So which is more powerful? NPDA is more powerful. Just now we have seen NPDA is more powerful than the DPDA. Okay. But this type 2 is a superset of type 3. Yes. So type 2 can also accept this. That is this NPDA, DPDA, it also accept regular language. Okay. So this PDA, push down automata, also accept the language that is accepted by the finite automata because it is a superset of this. Okay. So again, then type 1 that will be covering in the next unit. Type 0, type 1, these are accepted by the Turing machine, which is more powerful than all this. Okay. So we can compare relative powers like this. What? Language, regular language. I can write it this way. You can also note regular language, its power is less than CFL. Yes. Which is less than CSL. Okay. Which is less than unrestricted language. This can be the comparison, or the other comparison you may write what? NFA. NFA's power is less than. Can I write this way? This concept is very important. This is what the summary of our entire subject. Okay. NFA's power is less than what? DPDA. DPDA's power is less than NPDA, and NPDA's power is less than Turing machine. Here it can be NFA or the DFA because both are of the same power. Is it clear? Is the comparison clear or not? Any doubt here? Yes, number 36, H1. Is it clear? Many questions will be asked here about this. If you appear for GATE exam or any other competitive exam, this is what very important. You should know the powers of all this. Number 36, is it clear? Note down all this, whatever I am telling you. Number 36 है क्या? Let me check. Number 48. Number 48. So it's my request to all of you, if you don't want to pay the attention, don't attend the lecture. Again and again, I'm telling you. And this is not the subject like theoretical. Later on, you will read from the book or anywhere, you will understand it. Either you pay attention or you don't attend the lecture. See how many students I called and they are not replying. Kotkar sir. And I have already told that I am going to remove you if you are not going to reply next times. So today just I'm giving you warning. Okay. So those who are paying attention, at least is it clear to you? Number 11, Hunain,
Yes, ma'am.
is it clear? Whatever we have seen this.
Yes.
Okay. So let me again compare this for the NFA, DFA, NPDA, TPD. Okay. So language is accepted by NFA, DFA. They have the same power that we have seen. From this, which is more powerful? The language is accepted by DPDA. Language is accepted by DPDA. And from this, which is more powerful? Language is accepted by NPDA. It is the superset of this. Okay. Means what? NPDA can accept the language accepted by DPDA. DPDA can accept the languages accepted by NFA or DFA. So DPDA is more powerful than NFA or DFA, and NPDA is more powerful than it. Okay. So now, up till now, we have designed the NPDA or DPDA for the language. Okay. Now, we'll design what we have seen. Type 2, that is the context-free grammar. It is accepted by the NPDA. So let us directly design the NPDA from the grammar. Okay, we'll write the context-free grammar, and up till now हमने क्या किया? We directly consider the language and we design the flowchart for the PDA. Now, what we'll do? We'll design the NPDA for the grammar. Okay, so this part is very important. Please note down it. Note down किया सबने? Okay. So let us. The next my question is what? As I told that context-free grammar or the language generated by context-free grammar is accepted by the NPDA. Okay, so let us take the same example, well-formedness of a parenthesis. So well-formedness of parenthesis. So this is my grammar. Okay, so we'll directly design here. So we know that in the context-free grammar, all the rules are of the form what? A derives alpha, where A is a non-terminal, single non-terminal, which can appear on the left-hand side, and alpha is a sentential form, which is a string of terminals and non-terminals appearing on the right-hand side. Okay, so let us first write the algorithm. All of you write the algorithm. The first step, write down. What we'll do, see, first listen and then we'll write down. Okay, so what we'll do, we'll push the start symbol onto the stack. In the first step, push the start symbol onto the top of the stack. Then second step, pop the start symbol. Okay, and here we are considering leftmost derivation. So leftmost derivation, we know that at each step in a derivation, the production rule is applied to the leftmost non-terminal first. So second step may what we are doing, we are copying the start symbol and push the right hand side of the production rule in a reverse way. In a reverse way means what? Whenever this S is popped from the stack, when we push this right hand side, first we'll push closing bracket, then we'll push S, and then we'll push the opening bracket. Okay, so that is our second step. Push the right hand side. All these three will push onto the stack in the reverse order. Okay, so that after popping, you will get the leftmost symbol first. Third step is what? Whenever the terminal symbol is generated, when you pop, and if the pop symbol is a terminal. यहाँ पे terminal क्या है? This you know, this example is of what? Well formness of a parenthesis. So after you pop from the stack, and if the pop symbol is a terminal can be opening bracket or the closing bracket, then you have to check whether the input symbol read, whether that is also a currently popped symbol. ठीक है, अगर आपने ओपनिंग ब्रैकेट पॉप किया है तो इनपुट आपका सिंबल क्या होना चाहिए? ओपनिंग ब्रैकेट होना चाहिए. ठीक है, अगर आपने क्लोजिंग ब्रैकेट पॉप किया है तो आपका इनपुट सिंबल भी क्लोजिंग ब्रैकेट होना चाहिए. ठीक है, सो दैट इज आवर थर्ड स्टेप. फोर्थ स्टेप इज व्हाट? अगर नहीं मैच हो रहा है, इफ इट इज नॉट मैचिंग, देन you have to reject it. Okay, so in our case we are going to show only the accept case, remaining everything will be rejected. So fourth step is what? We have to continue the process till the entire input string is ended. Then when the stack is empty and the pop symbol is blank, you have to also check whether your input is also ended, and in that case finally your input string will be accepted. Okay, so note down all the steps. First step is what? Push the start symbol onto the stack. First step, push the start symbol onto the stack. Second step, after popping the start symbol, so first time I am writing this, later on for the second example you have to write this algorithm. After popping the start symbol, push the right hand side of the production. Push the right hand side of the production in reverse way. Third step, whenever pop symbol is a terminal, or if pop symbol is a terminal, read an input symbol from the tab. Read an input symbol from the tab and check whether it matches the currently pop symbol, and check whether